Right, ladies and gentlemen, welcome to a little review on features of functions. Yeah, just kind of remembering some of the things about functions. Just kind of overview of a bunch of things. So I'm going to show you. We're going to do a few of these, just kind of talk about what the different properties are, and hopefully that gives you a little recap of what's going on. Okay, so number one here. It's asking for domain and range. Remember, domain is the x's and the range is the y's, or the x's that the function has and the y's that the function has. So since this function is going left forever and right forever, there is the farthest left this will go is, well, negative infinity, and the farthest right it's going to go is positive infinity. This is very common to have negative infinity to positive infinity for your domain. Only if your function actually ends, such as 3 here, will you have something different. Like the domain on this is -4 to infinity because it goes from, well, -4 all the way to the right. So it can stop, and actually I need to have a square bracket on that -4 because it actually stops there. Anyway, back to number one. The range on this, once again, range is the y, so how far down does the function go, and then how far up does it go? Well, this is the highest it reaches, and that y value is 4. The farthest down it goes is negative infinity, so I'm going to put negative infinity 4. And since it actually hits 4, we're going to have a square bracket on 4 to include that number. And now it's time for end behavior. This is the limit of the function f of x as x approaches positive infinity. Positive infinity for the x's is to the right. This one is x is approaching negative infinity. That means left. So this is right end behavior. This one's left end behavior. As it travels right forever, it's going down forever. And so you're going to put negative infinity there. And then on the left side, it's also going down forever. So you're going to put negative infinity. Next part, increasing interval. When you're trying to figure out where it's increasing, decreasing, or constant, and you think as you go left to right, it's going up, or as you go left to right, it's going down. Increasing is up, decreasing is down. Weird. So if it helps, you can draw a little dude and kind of move the little dude along your function and be like, okay, as I go left to right, it's going up, 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 and then reaches up, and it's down, 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 down. And so it has an increasing part and then a decreasing part there. And so right out, it is increasing from negative infinity from the left forever until it reaches that highest point. And then it's decreasing from that highest point onto the right. If you're going to figure out what number goes there, you need to write down this x value here. And don't put the 4, you put 3, because it's over what x's, or what time, if you think of x as time. Over what time period is it going up? Well, from forever ago until 3 minutes, I guess. 3 seconds, 3 minutes, whatever. 3. Close that off. Close that off. Ta-da! We got our intervals. This function does not have a constant interval at all, so we put NA or none. Next part is where is it positive? Positive means above the x-axis. Positive as in positive y values. Well, these are all positive y values here. And so this interval starts here and then ends over here. Let me erase some of these extra marks I got so many extra marks, which is from 1 to 5. So I put from 1 to 5, open brackets there. It is negative to the left of 1 and to the right of 5. And so this is from negative infinity to 1, and this is from 5 to infinity. And so that makes our intervals there. We're right on both, negative infinity to 1, and then from 5 to infinity. And then something to mention, if you have more than one interval for a single property, you put a u there to combine them together, saying they're both involved in your answer. The x-intercepts and y-intercept, that shouldn't be a problem for you. When you write them down, I do want you to write them down as points, though. So this is your x-intercepts are going to be at 1, 0, and then 5, 0, instead of just at 1 and 5. So I'll put 1, 0, and then 5, 0. And since these aren't intervals, we're not going to put a u. You just put a semicolon or a comma there to separate out these points. Our y-intercept is just hanging out right here, and that's at 0, -5. Once again, on these, you put the points. Pretty much all this other stuff, this is all intervals. So yeah, you do have to keep track of what things are intervals, what things are points. And the next thing is minimum, maximum. This function, since it goes down forever and doesn't have a distinct lowest point in the area, so we're going to put none or NA. But it does have a maximum point, and that's up here. This is the highest point. And once again, this is a point, so you need to put the coordinates. So you're going to put 3, 4. So you're going to put 3, 4. And by the way, this is a global maximum. You can have a local maximum or local minimum. If you say something like here, this particular point is a local maximum. This point here is a local minimum. It's because they're not the highest or lowest point in the area. This would not have a global maximum or global minimum because this is points like these points are not the highest points in the area, and so you don't put any of these points as max or mins. Maximum is the highest in the area of points, and minimum is the lowest point in the area. So this only has locals, it doesn't have global. Let's jump to one where you have to draw the function. I'm going to use 7 as an example. When I do this, I like to just make notes on what's going on the picture and then fill things in. So my domain, it goes left forever, it goes right forever. The range is negative infinity to positive infinity, so it goes up forever and down forever. So it's going to have arrows going places. If I look at my end behavior, on the right side, it's going down. So I'm just going to put an arrow doing this. And then on the left side, it's going up forever. So again, I'm going to put an arrow there. All right, so I kind of got the ends, what's going on there. I'm actually going to take these. I don't need these right now because that also shows the domain and range. It is increasing from -2 to 3. So I'm going to put some little dash here. -2 to 3. It is going up. So I'm going to put a little mark there. Lets me know it's going up. It is decreasing before -2 and decreasing after 3. So this is going to be decreasing and then decreasing. So I kind of already got a kind of idea the function is going to do this. It's going to go down, up, down. So again, just putting some notes there. It's positive from negative infinity to -4, and then from 1 to 5. And so that lets me know, actually, I can put the points here. So actually, these bits of information share points. There's an X-intercept at -4, at 1, and 5, and lets me know that there's the shift in between negative and positive and all that stuff. So I'm going to put points at -4, 1, and 5, because I know it has to cross there. And I'm going to label where it's positive and negative. So it's positive here, it is negative here, it is positive. It's positive in this section, and then it goes negative. So positive, negative, positive, negative. Okay? And I know I have a y-intercept. That's a point I can put on my graph. 0, -1. Awesome. So I got distinct points here. The minimum is at -2, -4. So I'm going to put that point here. And I have a maximum at 3, 3. Goes like that. And really, once you have all these points here, you can kind of just connect. This is increasing in this section. So it's just from positive, negative. And it's decreasing in this section. And I know it needs to cross here. So, yeah. Through putting all those points around those notes down, it kind of comes together if you jot them down. So there you go. We're going to look at one more. Just a quick thing to remember, whether it's even, odd, or neither. Even means symmetrical about the y-axis, meaning if you fold along your y-axis and it's the exact same, then it's even. So something like this would be even. Something is odd if you can rotate it about the origin 180 degrees and it looks the same. So if you were to flip this upside down like this, it would be the same. So a function like this would be odd. So that's a quick thing. But kind of the big last thing you need to be able to do is determine if a function is even or odd algebraically. Algebraically. That means like using symbols and variables and stuff like that. So we're going to use 14 as an example. We are first going to test whether it is even. And to test if it's even, you need to figure out if f of -x is the same as f of x. Well, f of x is just the starting function, so I'm going to put that on my right side, which is this thing, 2 to the x power plus 5. The left side, you need to put in -x where the x is. So we're going to get 2 to the -x power plus 5. And when you simplify it, you just get 2 to the negative x plus 5. That is not the same as this one. And so this is not even. Well, okay, we tested whether it's even. It's not. Let's test if it's odd. And the way you test if it's odd, is if f of negative x, sorry, let me rewrite that. It is odd if f of negative x is the same as negative f of x. Okay, these are different, negative in a different spot, so it matters. We already got f of negative x over here, so I'm just going to write it again. It's this thing. So I got 2 to the negative x plus 5. Is that the same as negative, and I need to put what my f of x is, which is 2 to the x plus 5. Well, on the right side, we need to do some simplifying. We're going to distribute this negative here, and we get negative 2 to the x minus 5. Is that the same as 2 to the negative x plus 5? No, it is not. These have completely different signs. This is actually going to just be a positive thing, and this is just going to be largely negative. And so, yeah, these are not the same, so it is not odd, which means it is neither. Okay. If this was the same over here, we could have stopped and just said it's even. If these were the same, then we could say that it's odd. It was neither even nor odd, but yeah, you just gotta test it to see if things are even or odd. But there you go. There's a quick overview of the things from this unit you need to be able to do for your test next time.